Hey and welcome. Today we are going to solve diameter of binary tree interview questions, so let's get into it. First example here. We are given a tree and by diameter they mean the longest pass in the tree that may or may not include the root node. So in this case the longest pass could be either going from node 4 to tree or from node 5 to tree, and that is the longest pass which contains only 3 edges. Second example, we just have 2 nodes, so they connected by only 1 edge in between them, and that is what we are going to return. Let's see how we are going to solve this problem. The idea for solving this problem is super simple, and since we are looking for longest pass between 2 nodes, which this question calls it as diameter, definitely the obvious choice for tree traversal will be a depth first search. But as question description indicates, the longest pass may or may not pass the root node. It means we may have a case like this where diameter passes the root node, or this where longest diameter exists somewhere else in the tree. The first case is that we can have a recursive DFS on each subtree of root node and keep track of levels as we go down, then sum up those levels and return it. Well, that could be true if diameter would have passed the root node. What about this case then? In order to cover that case as well, we might reconsider some things. Let me show you. Here's a much simpler example that longest diameter does not involve the root node, and we are clearly looking for this pass or this one here. We still need to use recursive DFS to reach the leaf nodes first, and initially we will not care about how many levels we go down. The idea here is that we might keep counting levels as we go up in the call stack of recursive calls. In this case, currently we detected that we are at the end of this pass. That means we are in our base level of 1, and we will go back to node 4 in our call stack telling that the total depths we got from your left subtree was only 1. It will be the same for right subtree. No children means base level. Now the interesting thing will happen when we go back to node 4, where we are done with finding both subtrees depths, because in each level of going up in call stack we might compare the sum of both depths with whatever diameter we have found previously, and bigger becomes the new diameter. The thing is, that sum will point us to edges in terms of deep levels we found from that subtree, aka the longest diameter only from that subtree. Now once again, this time let's tell the parent node of 2 that how many levels it has in its left subtree, which is only 2 levels, 2 to 4, 4 to 6, or 7. But again, we have to do the same for its right subtree. If we do another recursive call here, we will hit the bottom level, and if we grind the recursive call stack toward up, we will end up with count of 3 levels. At this level, we will sum those up to represent the longest diameter we found in this subtree, which eventually will update our current diameter at here. Now, matter of fact, we already have found our longest diameter, because if we go up one more level, we will compare that 5 with either this diameter, which is 4, or this one, which is also 5. So there will be no update to diameter value, and that is the solution for this problem. Let's jump into the code to implement it. First, we need to initiate the diameter variable, which will be responsible for holding the longest diameter of all, and initially will be 0. Then we might create our recursive DFS function. We will call it longest pass, which will receive a root node to traverse it. Within this function, one of the base cases is that we don't receive any nodes, so in that case we will return 0. Otherwise, we will do our recursive calls on each subtree of the given node. Now, the sum of levels we get from both left and right subtrees will be the competitor to what we have already stored as diameter so far. The bigger, the winner. And at the end of this function, we are clearly know that we are in a node that has children. That means it's the time to decide which subtree has the biggest levels count, and of course +1, because we might count the current node as 1 level in order to report it to the upper node. Now, if we get out of that function, of course we need to call it on a root node, and after it's done, our diameter variable will be updated and we might return it as of our end result. Now if I run this, test cases are passing, and if I submit, we are in a good shape here. Now let's jump into the slice for time and space complexity analysis. So the time complexity will be O of n because of our recursive DFS function, and of course it makes sense that we might visit every node in order to figure out the longest pass. And the space complexity will also be O of n because of, again, our call stack of recursive functions. So that was it for this video. Thanks for watching, and please leave a like, comment, and subscribe to the channel. I will put a few more links about different playlists in the description for you to check it out. And finally, hope you enjoyed this video and stay tuned for the next one.